Okay, so this is the homework help math video for Honors Math 3, Unit 7, Worksheet 5. So most of these are just review questions, so hopefully that is what it feels like. So we're going to take a look at question number 6 first. So our goal here is to isolate the x. So in order to isolate the x, we need to get rid of the 15. So I'm going to divide both sides by 15. And then I get 41.8. And then I'm going to go ahead and write the power there as a radical. So this is review from a couple chapters ago. So I have x is to a power of 5 and a root of 3. So root of 3, power of 5. And then to get rid of the cube root, I want to raise that to the third power. And then to get rid of the power of 5, I want to take the fifth root. So then x would be equal to the fifth root of 41.8 cubed. And then I'm just going to do that in my calculator. So you should have like somewhere a button. So let me zoom out just a little bit here so we can see that. So somewhere you should have a button that has like x with a root on it. So in the graphing calculator, I would find that under math. So if I press the math button, so this one right here. So if I press math, so do you see how I have like that x with that root? So that's the button or something like that that I'm searching for. So I'm going to quit though. So if I want the fifth root, I need to hit the 5 first. I'm going to hit the 5 first, and then I'm going to go to math. And then the number 5, so I'm going to go down to that one there. And so that gives me that fifth root, and then 41.8. And then to a power, so my power key is that caret key above the division, and then 3. And so the directions say to round to the nearest thousand, so that would be 3 decimal places. So then I would have, for here I would have 9.39 and 1. Okay. All right, and then let's take a look at question number, let's see, how about 11? So we haven't done one of these in a while. So 11, this is off of your objective 3 notes. So for this one here, so the first thing we want to do is condense or combine the logs. So I want to combine these. So I'm going to make 2 a power onto x, so that would be x squared. And then I still want to combine these, so to 1 log, so that would be log base 3. And then whenever we're subtracting logs, then we divide their values. So then it would be x squared, so the left, over the right, which is x minus 2. And then still equal to 2. And then from there, I want to get rid of the log base 3. So I want to make this a power on 3. So this becomes a power on 3, and whatever I do to the left, I have to do the right. So it'll be 3 to the power of log base 3. And then 3 to the power of 2. So all I did was make both of these powers onto 3. And then over here, 3 log 3, since our inverses would cancel. And so then I have x squared over x minus 2, and then that's equal to 3 squared, which is 9. And then I want to clear my fractions, so I'm going to multiply both sides by x minus 2. And so that would cancel. So over here I just have x squared by itself, and then here I'm going to distribute the 9. And then because I have a quadratic, I want it to be equal to 0. So that means the 9x and the 18 need to subtract to the other side. So when I subtract 9x over, and then I'm going to add 18. So I'm going to do that without showing any work. So I have x squared, and then I'm going to subtract the 9x, and then add the 18. And then that would just make it equal to 0. And then once I get in here, I want to factor it. So I'm looking for my factors for 18. So that would be 1 and 18, 2 and 9, 3 and 6. So 3 and 6 should work. Both negative. And so then that would give me values for x being positive 3 and then positive 6. And then because I'm working with logs, I want to verify. So I have 3 and 6 here, so that would be fine for both of these because that would not give me a negative on either one. Okay. And then let's go ahead and take a look at question number 13 as well. So this one here, we want to solve for x in terms of y. So that means we're going to get like an equation. So it'll be x equals and then a bunch of stuff with that y in it, right? So we want to isolate the x. So I want to get x by itself. So the first thing I want to do is get rid of that negative 62.5 in front, right? So we start from the outside, work our way in. So that means I'm going to divide both sides by negative 62.5. And so that would give me 1 right here. No, I'll just have Shira do it for me. Thank you, though.
All right.
Okay. All right, you too. Okay, I will. Thank you. Okay, bye-bye. Okay, sorry about that interruption there. All right, so then I would divide. And then over here I would still have the natural log. And so from there then, now I'm still trying to get x by itself. So I still need to get rid of the 80, the 1, and the natural log. So then I'm going to get rid of the natural log first. And so I would use base e, right? So this is base e here. And so this would be e to the power. And then when I do e to the power over here, so I'm just going to kind of be lazy about that. So when I do e to that power, it's going to end up canceling. So I'm not going to write that step down, and so then I'll just be left with this. Okay, so again, just to kind of make sure. So I want to get rid of the natural log, so I have to exponentiate both sides. So this will become e to the power, and then e to the power, but e and ln will cancel, leaving just that value. All right, so still trying to solve for x, so I still have to get rid of the 1 and the 80. So then next I'm going to get rid of the 1, so that's positive 1, so I'm going to subtract 1 from both sides, and then that will cancel. And so then I'm going to just move that up over here a little bit. So I'll have this minus 1, so e to the power of y over negative 62.5, and then minus 1 is not up in the power, and then equals x over 80. And then the last step is I want to go ahead and then multiply by 80 to get rid of that. So then when I multiply the 80 over, I will have 80 times that quantity. And then equals x, and that would be it. Okay, and then let's take a look at a couple of the word problems. Okay, so quite a few of these we did in notes or something like them in notes. So let's take a look at 17. So I put an in by the notes one, so I'm not going to do any of those. Okay, so you check your notes for those too. All right, so let's take a look at 17. So again, the first thing I'm going to do is just kind of look for my numbers here. So I have 10,000, I have a 7, and I have a 25. So I just want to kind of underline those so that when I read through it, I'm like kind of focused on those numbers and what do they represent. So it's saying that I have $10,000 that was invested. So that means I had 10,000 and I invested it. So that would be my principal amount or initial amount. So that would be P. And then I'm investing for 7%. So that would be my rate, my interest rate, right? And so as a decimal, so that would be 0.07. And then it's saying compounded continuously. So that's a separate formula, right? And that formula, again, this is in your notes. So that's that compounding formula. Whoops, that's totally not right. Or cross that off. So how about A equals and then PE to the RT? Okay, so there's that formula there. So ignore that one. And so that was, we want to know how much is it worth. So A at the end of 25 years. So then that gives me that T is 25. Okay, so again, I just kind of read through and try to figure out what each of those different numbers are. And so once I do that, then I want to put it into that formula. So I'm looking at this formula here. So A is what I'm trying to figure out, right? How much money I have after I invest it. So I don't know A. And then my value for P, so that was over here, so that's 10,000. And then the E, so the base of E, and then R, so there's my interest rate, so that would be 0.07, and then times my value for T, which was 25. So it looks something like that, and so now I just need to figure out how to type that into my calculator. So first I'm just going to multiply my powers together, so I'm just going to do 0.07, and then times 25. And then now I'm just going to go ahead and type that all into my calculator here. So let me actually zoom out one more time. So clear that out. So when I type that in, so I'm going to do the 10,000. And then my E, so my E is above my natural log. So if I look here, I have a E above my natural log. So I'm going to press that button by hitting second and then E. So that gives me the little E right there. And then now to the power of 1.75, and then just hit enter, and then that would be my answer. So we're working with money here, so I'm going to go ahead and round just to the nearest hundredth. So that would be $57,546 and then 3 cents. Okay. And we are going to call that good for this one.